And welcome back, students. As we get into our next lesson on text files, we're going to today discuss appending a text file. But before we get into that, I just want to talk about a couple things that build off of when we talked about last time when we discussed creating a text file via output. So here's a quick pitfall. A try block is still a block. Right? So if you recall, in our text file output demo, we declared the variable output stream outside the try block. Now, if we move that declaration inside the try block, we get a compiler error message. In fact, I said, you can't have it inside because if you put it inside, it may not exist. So if we suppose we replace print writer output stream with null, try output stream with new print writer, new file output stream self.txt, with the following, you'll notice that we just declared it all inside of it. With that replacement, while it might look innocent, it actually makes the variable input stream a local variable to the try block. In other words, you can't access it outside the try block, which means that you could not use output stream outside of the try block. It would be limited to just what you're doing in the try block. If you make this change and try to compile the change program, you will get an error message saying that output stream, when used outside the try block, is an undefined identifier. Additionally, another pitfall to avoid is overwriting that of the output file. Now, we can, of course, just run it multiple times and generate new output files. But when you connect a stream to a text file for writing to a text file, as illustrated with files, you always produce a new file. Output stream is new print writer, new file output stream stuff.txt. If there's no file named stuff.txt, it's going to create an empty file named stuff.txt until we specify something to be written into it. It's just going to be a blank text file. Now, if a file named stuff.txt already exists, then this will eliminate for that file and create a new empty file named stuff.txt. So if there's a file named stuff.txt before this file opening, then all the data in the file is lost. So pretty much it just takes anything in it and deletes it because it destroys the old copy and makes a new copy. Now, in a later lesson, we will test to see if the file already exists so you can avoid accidentally overwriting a file, which is a very good thing to do because the last thing you want to do is, of course, overwrite a file if you don't need to. So for now, let us explore how to add data to a text file without losing the data that's already in the file. Right? And that is known as appending. Appending to a text file. So this you can also think of as amending a text file is the way you can think about. But when you open a text file for writing, the way we did in the text file output demo, and a file with given name or exists, the old contents are lost. It just overwrites and deletes it. However, sometimes instead you want to add the program output to the end of the file. This is called appending. So you run the program once, create some output in a text file, then you want to run some other stuff, it's going to stick it on the end later on. Or you have a file that already has data in it, you want to add more data to it. So if you want to append a program to the file stuff.txt, connect the file to the stream output stream in the following manner. Output stream equals new print writer, new file output stream stuff.txt, comma, true. You'll notice it's very identical except we have the comma true on there. The comma true is what it indicates it's going to be an appending. Now, if the stuff.txt does not already exist, Java will create an empty file with that name and append the output to the end of the empty file. So even though if it doesn't exist, it just appends it in from the end. This is how it works. It just always goes in from the end. If it does exist, it's going to go after this thing. So since there's no file named stuff.txt, the effect of opening the file is the same as in text file output demo. However, this is what the difference is. If stuff.txt already exists, then the old contents are already going to remain. Let's just say it had before the numbers 3, 5, and 7. And then our new stream is going to add, let's say, the number 17. Well, with text file output demo, if you open the text file, the way we did it is going to just be 17. But with an appending, it changed to 3, 5, 7, 17. So the program's output then is going to be placed after the old contents of the file. Now, when appending to a text file, you still use the same try catch blocks as we did in the text file output demo. Now, that second argument of true deserves a bit of explanation. So, you notice it was comma true. Why not comma false or some other value? So why did the designers say, let's use true to signal appending? Or why not use something such as a string append? And just say, hey, when you see the keyword append, why don't you do this? Well, the reason that Java developers have it this way is that the version of the constructor for the class file output stream was designed to allow you to use a Boolean variable or expression to decide whether you want to append an existing file or create a new file. So, for example, the following might be used. System on the print line, enter A for append and for new file. Chart answer. Use your favorite way to read some character in the variable answer. So it'd be like, scanner keyboard, next. Then eventually you have Boolean append is equal to answer equals A or answer equals lowercase a. Output stream equals new print writer, new file output stream stuff.txt, comma append. Now, from this point on, your program writes to a file in the exact same way that the program in the text file output demo does. If the user answers with upper or lowercase a, then any input added after the old file will be added after the old file contents. If they answer with upper or lowercase n or anything other than a, then the old contents of the file are lost. Now, one more quick tip for you is that the toString method can help you with text file output. In program 1, if you recall, we noted the class as a suitable toString method. An object is an object of the class. Then, an object can be used as an argument to system.println, which produces some constants of output. Now, the same kind of methodology that we did back then, we did a lot with like the day class, for example. We did toString, we print out values of the month, the day, and the year. But the same kind of thing applies to methods println and print of the class printWriter. Both println and print of the class printWriter can take any object as an argument and will produce reasonable output so as long as the object has, ready for it, a sensible toString method. So the toString method, once again, is going to be very important. toString and equals are some of the most important methods you can have inside of your classes. Alright, and that's going to wrap it up for today, folks. So, we'll see you next time.